Hello everyone, I am Mr. M. Vignesh. Now let's look at the characteristics of practical silicon diode as a continuation of the topic diodes. So these are the topics to be covered as we discussed in the previous lecture. So far we have discussed about electrical properties of solids, semiconductors, doping, ideal diode, PN junction, forward bias, reverse bias, IV characteristics. Now we'll move further, we'll go through the practical silicon diode. Now let's look at the characteristics of a practical silicon diode. Unlike an ideal diode, a practical silicon diode requires a minimum forward voltage of about 0.7 volts before it starts conducting current efficiently. This is known as the cut-in voltage or forward voltage. Every diode also has a breakdown voltage, which is the maximum reverse voltage it can withstand before conducting heavily. In addition, diodes have a maximum current rating. Exceeding this value may damage the device. Therefore, while designing electronic circuits, it is important to select a diode with a suitable voltage and current rating. This graph shows the current voltage characteristics of a practical silicon diode, that is practical IV characteristics. Notice that the diode has very different characteristics. That is, it doesn't conduct immediately when a forward voltage is applied. Current starts increasing significantly only after the forward voltage reaches approximately 0.7 volts. In reverse bias, only a very small leakage current flows until the reverse voltage reaches the breakdown region. This practical behavior is considered while designing the electronic circuits. Now let's look at the special purpose diode. We'll start with light emitting diode. One of the most common special purpose diodes is the light emitting diode or LED. Unlike an ordinary diode, an LED emits light when it is forward biased. The color of the light depends on the semiconductor material used. LEDs are widely used in indicator lamps, display panels, traffic signals, televisions, automotive lighting, and energy efficient household lighting because they consume less power and have a long operating life. Next one is Zener diode. Then Zener diode is also a special purpose diode. A Zener diode is designed to operate in the reverse breakdown region. Unlike an ordinary diode, it is safe. It means that it safely conducts current after reaching its Zener voltage. Because of this property, it maintains a nearly constant output voltage even when the input voltage changes. For this reason, Zener diodes are commonly used as a voltage regulator and voltage reference circuits in electronic power supplies. Schottky diode. A Schottky diode is different from a normal PN junction diode. It is formed using a metal and a semiconductor instead of a two semiconductor materials. Its major advantages are a very low forward voltage drop, typically around 0.25 volts, and very fast switching speed. Because of these characteristics, Schottky diodes are widely used in high-speed digital circuits, switching power supplies, and communication equipment. Tunnel diode. A tunnel diode is a heavily doped semiconductor diode. Due to heavy doping, the depletion region becomes extremely thin. This allows electrons to pass through the junction by a process called quantum tunneling. Tunnel diodes exhibit a negative resistance region, making them useful in high-frequency oscillators and microwave circuits. Although they are less common today, they are still used in specialized electronic applications. Varactor diode. A varactor diode, also called as a varicap diode, always operates in reverse bias. Its depletion region behaves like a capacitor. When the reverse voltage changes, the width of the depletion region changes, causing the capacitance to change. Because of this property, varactor diodes are used as a voltage controlled capacitor in radio receivers, television tuners, communication systems, and frequency modulation circuits. One important application of a diode is the half-wave rectifier. A rectifier converts alternating current or AC into a direct current or DC. During the positive half cycle of the AC input, the diode conducts and current flows through the load. During negative half cycle, the diode blocks current. As a result, only one of the AC waveform appears at the output. A capacitor is often connected across the output to reduce the ripple and obtain a smoother DC voltage. Full wave rectifier. A full wave rectifier is more efficient than a half wave rectifier. It uses 4 diodes connected in a bridge configuration. In this circuit, both the positive and negative cycles of the AC inputs are converted into the same polarity at the output. Since both half cycles are utilized, the output is smoother and the ripple voltage is much lower. This is why full wave rectifiers are widely used in power supply circuits. Signal rectifier and clamping circuit. The diode can also be used for signal processing. A signal rectifier, also known as an envelope detector, is used in radio receivers to recover original audio signal from an amplitude modulator, that means AM signal. Another important application is signal clamping. Clamping circuits normally shift the voltage level of a signal without changing its shape. These circuits are ordinary diodes or Zener diodes, are commonly found in the communication and digital electronic systems. So these are all some circuit illustrations for clamping. Next one is catch diode. A catch diode is also called as a flyback diode or freewheeling diode. It is used in when switching inductive loads such as relays, motors, solenoids. When power is switched off, the collapsing magnetic field produces a high reverse voltage called back electromotive force or back EMF. The high voltage can damage electronic switches. The catch provides a safe path for the stored energy, protecting the circuit from voltage spikes. So let's summarize the lecture on diode, including the previous lecture. In the previous lecture, we have seen about diode and its basic characteristics and how the diode is formed, starting from semiconductors and material property. A diode is a semiconductor device that allows current to flow in one direction while blocking it in the opposite direction. It is formed by joining p-type and n-type semiconductor materials to create a p-n junction. We studied the depletion region, potential barrier, forward bias, reverse bias, and the current voltage characteristics of the diode. We also learned about the practical silicon diodes, special purpose diodes such as LEDs, Zener, Schottky, tunnel, and Varactor diodes, along with their important applications. Understanding these concepts forms the foundation of many electronic circuits and systems. So that's all about the semiconductor device diodes. We will see you with the next topic in the next lecture. Thank you for watching this lecture. I hope you found it informative and useful. See you in next lecture.